specifically creating objects, moving objects around in 3D, and understanding perspective inside of an expression scene. So to get started, we're going to work inside a blank project, and we're going to work inside of scene 1, which is just my default blank scene. We're going to create a few different objects. We're going to move them around inside of our workspace and talk about the different ways that we can move those objects around, what tools are available inside of Expression to move those objects around. We're also going to talk about object grouping and how we can affect multiple objects together. So to start off with, first you need to understand the relationship between your object library and the object manager, which is down here in the bottom left-hand corner of the screen. I'll expand this window a little bit so that you can see it. In the object manager, you'll see every object that you create as a node in a tree structure. So if I go ahead and create a quad object, which is basically just a flat rectangle, you'll see that that quad then populates inside of our object manager, and it's called quad 1. As you create objects, it's always a good idea to rename these, naming your objects according to what purpose they're going to serve in your scene. So if this quad was going to be used as a background, for instance, I would call this background. Or if it was going to be used for a banner for a lower third or something to that effect, I'd call it banner. Whatever name makes sense. Now, in terms of moving this object around, there's a few ways that you can do this. You can click inside the viewport to make selections, and you can also hold down the control key and then use your mouse to drag objects around inside the viewport. So if I hold down the control key, I can then click on this object and drag it around inside the viewport. Now, because we're working in 3D space, I'm only affecting this object on two axes. I'm only affecting it on the X and the Y. So X is my horizontal, Y is my vertical. The other option for moving objects around in the viewport is by using the object manipulation tools in the toolbar. So at the top of the screen, you'll see currently we have the mouse cursor, or the selection tool, activated. And if you hover your mouse over these different options, you'll see the description pop out. So we'll see the next option is the move tool. The option after that is the rotation tool. Then we have a scaling tool and a pivot tool. Each one of these is used to affect those specific attributes of this object. So if I select the move tool, it'll then activate handles where I can affect the X and Y position, or the X and Y position in this case. So I can grab the Y handle and I can drag the object vertically, or I can grab the X handle and I can drag the object horizontally. This still doesn't really help me though if I want to move the object forwards or backwards in 3D space, so on my Z-axis. So in order to do that, oftentimes what you'll have to do is open another viewport. And this is where working with perspective and understanding perspective in 3D space becomes important. We're only looking at our scene right now through the front perspective. So I see a straight-on view of this scene. I can always open another viewport that can be assigned to a different view of my scene. For instance, the left, the right, the top, the bottom, etc. So if I go to the Windows menu, I can select a new viewport, which will create a new viewport. By default, that viewport is looking at our scene from the same perspective as the main viewport. But I can switch it by going to the Camera tab and selecting a different default view, for instance, the left. So now I'm looking at the left side of my screen. And because we're looking at the scene from the left, our quad basically looks like just a flat plane. Right? We can't really see the face because the face is not pointed towards us in this case. But what I can see is the Z handle for movement. And I can actually grab that handle and drag my object forwards and backwards on the Z axis now. And you'll see how that reacts in our front viewport. So working with multiple viewports is very handy. First of all, it gives you greater access to these tools, and it also gives you some perception of depth. If I had more than one object in the scene, I'd very easily be able to see where this object is in relation to any other object in the scene on the Z-axis by looking at it through a different perspective. All right, so we can move objects around, like I said, by holding down the control key or using these movement tools. There's also a tool for rotation. So if we select the rotation tool, I can now affect rotation on this object by grabbing the different handles. I can also affect scale, and I can also affect the pivot position, which essentially offsets the object from its anchor point. which will then change where the obviously where the object is anchored and where the object rotates from or scales from or its position is calculated from. So now you'll see that my object is rotating off of that new anchor position that I've established. Now, generally speaking, moving objects around in the viewport works very well for quick adjustments. But if you want to make very precise changes to an object, my suggestion and my preference personally is to use numeric adjustments so that you know exactly what value or exactly what coordinate your object is at on a specific axis. And to do that, there's a few different methods we can use. Inside the Object Manager, you have all of the coordinates presented to you in different columns. So I have my X position, my Y position, my Z position, XYZ rotation, XYZ scale if applicable. All of these fields are editable. So I can go to the X position and I can scrub that value. And to scrub, what I'm doing here is I'm clicking on the number with the left mouse button. So click, hold, and then push the mouse vertically to scrub that value. You can also just type in a value. So for instance, if I want this to be at 600 pixels on the x-axis, I can just type in 600 and it'll place the object at that position. And that goes for any of the values in these columns, including transparency, which is represented by this alpha value. So we can adjust that as well, and you'll see that my object becomes transparent in different increments. So those options are all available to you in the Object Manager. The next place where we can handle object manipulation is in something called the Transform tab. And you'll find the Transform tab in what's called the Object Inspector window. Now, the Object Inspector window is an interface in the UI that shows us all of the related options to the currently selected object. So as I move through my Object Manager and select different objects, the Object Inspector follows my selections and shows me the relevant options. So for instance, if I select my scene object, I'll see options tabs that relate to the scene object. If I select my light, options that relate to the light. If I select the quad, I have options related to the quad. So the Transform tab is right here. You'll be able to adjust position, rotation, scale, and pivot from this interface. The nice thing about it, and the reason I like the Transform tab, is I can see all of the coordinates at a glance in a very organized column view. So I see all of my positional coordinates, I see all of my rotation, scale, pivot. I see everything in relation to one another. So I can very quickly establish where this object is in my workspace. And there's also some nice features inside the Transform tab that allow us to make precise adjustments. So for instance, I'm adjusting position right now in 1 pixel increments. As I scrub this value, we're moving in 1 pixel increments. But I can change that. If I need to make fine adjustments, I can switch that to 1/10 of a pixel, 1/100th, or 1/1000th of a pixel to make those adjustments as well. And now I'm making very, very precise changes to the position of that object. Place this back in the center. Same thing goes for rotation. We've got X, Y, Z rotation, so we can affect our rotation, X, Y, and Z. You can also change the rotation order, depending on how you want these axes to be interpreted, either X, Y, Z, Y, Z, X, etc. And the scale. If we affect scale, you'll see that right now by scrubbing the X value, I'm scaling this object symmetrically, meaning that X and Y are scaling in unison. But we can break that link. So if we're looking at the scale area of this interface, you'll see an option that tethers X and Y, and you'll see an option that disables that by selecting none. And now I can affect the Y and the X scale independently. All right, so let's center these all back up. Let's change our scale back to 1. Let's center our rotations. And we'll move on to the pivot column. The pivot column is very, very handy for moving your pivot point around. For one, you can see the X, Y, and Z position of your pivot, and there's also some quick centering tools here as well to get your pivot in a specific spot on the object or to center it on a specific axis in the object. So if I wanted to take my pivot point and move it to the far left edge of this quad, I can adjust the X position of my pivot. Now what you're seeing here is the rotation tool is shifting, but the object is not, and that's because of the lock position object, or lock position option, I should say. The lock position option keeps my object static while moving its anchor point across the surface of the object or within the object. You can see your pivot point when any of these tools are activated. So all of these movement tools, the rotation, the move tool, the scale tool, the pivot tool, they all place themselves on the pivot point. There's specifically a pivot tool. The nice thing about the pivot tool is it's much smaller and you get a much better idea of where your pivot actually is, whereas the rotation tool has this large gimbal which is a little bit vague in terms of where it might be anchored on the object. So I like to turn on the pivot tool when I'm doing this, and then I can shift my pivot in any direction. So I'll place the pivot on the far left edge. Now what does that do for us? Well, now that we've moved the pivot to the far left edge, you'll see a few different things happen. For one, my X position is changing, even though the object itself is not moving. The reason that value is changing is because by moving this pivot, I'm changing where we calculate this object's position from. So previously, the pivot was located in the center of the object, and because the center of my object is at 960 on the x-axis, my x position is 960. But if I shift the pivot to the left, I'm now in line with 720 pixels on the x-axis, which is this current position. So we're now calculating this quad's position from its left edge. Also, when you move your pivot point, it shifts where we rotate from. So now I'm rotating off of that left edge. And lastly, it also changes where we scale from. So now you'll see when I scale this object, it scales from its left edge. So moving your pivot points is very, very useful when it comes to creating animations, because you may not always want objects to rotate from their center position or scale from their center position. You may want to create an animation where this object scales from its left edge. And the only way to achieve that is by moving that pivot point to the appropriate position. Now, if you want to move your pivot point to a specific center position, for instance, center of the object or center on the x-axis, center on the y-axis, we have some quick centering tools here as well. So as an example, I'm going to move my pivot point to the upper left-hand corner. Now, if I want to center this pivot specifically on the x-axis, but I don't want the pivot to shift back on the y-axis, I can just hit center X and the pivot will move to center on the x-axis while remaining positioned at the top of my quad object. Of course, I can do the same by hitting the Y centering option, which will center my pivot point on the y-axis, but keep the pivot positioned on the left edge. And if I want to put this pivot point back to the absolute center on the object, I can just hit the center button and it'll move it back to the center. And now we rotate from the center, we scale from the center. All right, the next thing we're going to talk about is object grouping. So in your object manager, you can have many, many objects. It's not outside the realm of possibility to have hundreds of objects that make up a single scene. So a really effective way of organizing those objects and helping you move those objects around in an efficient manner is by grouping objects to one another, or basically creating parent-child relationships inside of your object manager. So what I'm going to do next is I'm going to create a cube object. Doesn't really matter which object you create. I'm just using a cube as an example here. So here's my cube. Now I want the cube to follow the quad. So in order to create a relationship between these two objects, all I have to do is take the cube and drag it on top of the quad. And you'll see that there's now a link between these two objects. The cube is now a child of the quad object. So if I move the quad left and right, the cube follows. If I move the quad up and down, the cube follows. If I rotate the quad, the cube also follows. And notice how the cube is rotating based on the quad's pivot position. So the cube is effectively swinging around the quad in this scenario. Now, there's no limit to how many steps you can create in this tree. So if I wanted to create another object and have it as a child of the cube specifically, I could also do that. So I could take the torus and we'll make it a child of the cube. Now, if I change the position of the quad, all of my objects move. If I change the position of the cube, only the torus moves, because the torus is a child specifically of the cube, and the quad is not affected by its child object in this case. And then, of course, if I go to the torus and make changes here, it's sort of acting independently, or it is acting independently in this case. So pretty straightforward, but this can be extremely useful, especially when you're creating complex animations. Oftentimes, something that looks fairly simple will be made up of multiple objects. For instance, I'll have a text object that's paired to a background object, and I want to slide those both together into my scene, or create an animation that reveals those objects together. The most efficient way to achieve that, instead of having to keyframe everything individually, is by grouping them. And then really we only have to animate the parent object. All right. Now, the next method for object grouping is using something called a group object. So in the previous example, we used the objects themselves, the quad, the cube, the torus, as the parent object. But what you can also do is create a group object. So at the bottom of the object library, there's an object called a group object. And if you create the group object, it'll appear in your object manager as this icon, group object. I can take all of these objects that I'm using and make them children of the group. So I can actually do a multiple selection here. I'll just hold down the Shift key and I'll select these three objects and I'll drag them into my group object. Now the cool thing about the group itself has no visible attributes. It has no faces. I can't assign materials to it. It's really just a container. So if you're used to working in, let's say, After Effects or compositing applications like that, oftentimes you'll be able to create null objects. An object that's really just a holder or a positioning object for others. Basically, an element that you can use to position other objects in the scene. The group is very similar. It itself has no visible attributes, but I can use it to drive rotation and position for all of its children. The other really effective use for the group object, and this is unique to the group object specifically, the group object controls the transparency of its children globally. So if I affect the alpha value of the group object, it affects the alpha of all of its children. So naturally, you can start to see some use cases for this. If I put multiple text objects, for instance, or multiple lines in a table that I'm building inside of a group object, I can animate the opacity for all of those children objects together. You can also toggle the visibility for all of those objects together. So once you start getting into some more advanced techniques, for instance, if you want to create conditional effects in a scene where there's a certain value represents certain objects being visible or not visible. For instance, I type in the number 4 and I get 4 lines on my full screen. I type in the number 8, I get 8 lines on my full screen. Well, oftentimes what we're doing in those situations is toggling the visibility on group objects to give you those different layouts. So the scene itself actually contains all of the objects, the maximum number of objects, but we'll use the group object to control the visibility of certain sets of objects to make more flexible templates. Right, pretty straightforward stuff here. Now the last thing I want to cover in this tutorial is perspective, and this is something I see people do a lot when they're new to working in 3D space and new to working with expression. But every scene that you create has perspective, and the distance between objects can greatly affect how you interpret perspective, or how you at least interpret the distance between different objects. So here's a mistake I see a lot of people get caught with. So I'm going to delete these objects, and we're going to create a sphere, and we're going to create a quad. Now I'm going to position my sphere slightly forward on my z-axis, so I'll move it forward. Now, something I see a lot of new users do is to affect scale. Sometimes we get caught in affecting position instead of scale. And what I mean by that is when you move an object forward on the z-axis, it affects its perceived scale, right? So because it's getting closer to us, it is in effect getting larger. But it's not really getting any bigger, it's just getting closer to your eye. So what can happen in this scenario? Well, I'm going to apply some materials to this just to illustrate the point a little bit better. So I'm going to make a new material. I'll make a red one, and I will make a white one. So new material. I'll apply the white material to my quad, and I'll apply the red material to my sphere. Right? So we've got a red sphere, and we have a white quad. Right. Now you'll see that as I move the quad forward, it gets larger. And at a certain point, it actually intersects the sphere. But you could be in a scenario where the quad itself is already significantly larger. You may have already scaled it. And now to make it larger or smaller, you start moving it forwards or backwards on the z-axis. Now, when the object stays stationary, this looks fine. But if you were to start moving these objects around, you're going to start to see some negative effects here, right? As I move this object further behind the sphere, it gets smaller. But let's make the quad a child of the sphere, and we're going to move the sphere left and right. And watch what happens. It looks like the sphere is drifting from left to right. And what we're seeing there is the effect of perspective in the scene. Basically, simulating what your peripheral vision would create if you had, great separation between objects. So as one moves to the left, because the distance is so great between these two objects, it appears that it's drifting to the left and drifting to the right. But really, we're just seeing around that object. And because the sphere is moving to the right, and it's closer to our eye in this case, we now see the quad behind it. Right? So to combat that, it's just important to understand the difference between scale and position. And once you understand this, it's pretty straightforward. But if I take that quad and move it closer to the sphere, to the point where they're actually intersecting one another, and use scale to affect how large it is, you'll see that now we have very little drift because there's very little separation between those objects. And if you look in my left viewport, you'll see exactly what's going on here. Another reason why the left viewport, or having another viewport, be it the left, the top, or the bottom, gives you a good idea of separation between objects and a good idea of perspective inside your scene. So that's object manipulation. Stay tuned for more tutorials. Come back to the site and follow along with us. Thanks very much, and we'll talk to you soon. Bye-bye.